Okay, let's talk about our final gas law. This is the ideal gas law. Before we talk about this, we need to know a few terms. First term you need to know about is STP. STP stands for standard temperature and pressure. And standard temperature is 273 Kelvin, and pressure is 1 atmosphere. So if anyone tells you, oh, that gas is at STP, they're really meaning that it's at 273 Kelvin, which you should know by now in Celsius. That would be freezing point of water, and at 1 atmosphere. Now, the equation for the ideal gas law is PV, pressure and volume, pressure times volume, equals N R T. And you should know that T is temperature. Temperature has to be in Kelvin. N here in this equation stands for the number of moles. And R is a constant, a number that doesn't change if you use certain units. So the units we're going to need to use in this is liters, atmospheres, moles, and Kelvin. And when we use those units, R will always be 0.0821. You need to memorize that number. Okay, let's see how this works. Let's say that I have 1 mole of any gas, it doesn't matter what gas it is, and it's at STP, and we want to know what volume it occupies. Well, first, let's go ahead and solve for V. So, if I use my algebra skills, PV equals nRT. If I divide by P, I'll have V by itself. So from here, all I need to do is plug in what numbers I need. So N was the number of moles, and I had 1 mole. R is always our 0.0821. Liters, atmospheres, moles, Kelvin. T is standard temperature, so that's 273. And pressure is standard pressure, so 1 atmosphere. Okay. Now, if you'll look at the units, the reason why R has to have these units is because they will all mark out and leave just the unit I want, this liter here. So if I go about that math, I take 1 times 0.0821 times 273, divide it by 1, I will get 22.4 liters. And why did I put 3 numbers here? It's because I had 3 numbers in my Kelvin. And then I also have 3 significant digits in my R. Okay, this 1 atmosphere, I assume that it's 1.000, as many as I need to. In my 1 mole, I'll assume it's 1.00. So I'm going to pick up my significant figures from my temperature. Okay, pretty easy. The only question I've had through the years with this is, how do you know when to use the ideal gas law and when to use the combined gas law? Remember, the combined gas law is our PV over T equals P2V2 over T2. The combined gas law is for when something changes. When you have a certain pressure and a certain volume, but your temperature changes. Or you have a certain temperature and a certain volume, but your pressure changes. And you're looking for what's the new pressure. You use the ideal gas law when nothing changes. You're just given the initial conditions. You have a certain pressure and you have a certain volume, and you want to know the temperature. So nothing changes from volume to volume or pressure to pressure. All right, pretty easy.